Good evening, everyone. For this live session, we'll wait for 5 more minutes for more students to join, and then we will start the class. Okay, students, it's already 7:05 and most of the students have joined the session. So now we will start the session. Once again, welcome you all to this live session 9. Uh, this live session is for physics of renewable energy system. Course is taken up by Professor Amit Chandra, who is from Department of Physics at Renewable. Live session is conducted by me, Rohit. I am a scholar at IIT Bombay. Okay, so far, I assume that you all have a great weekend. Um, Also, you have gone through the different course lectures, videos which have been uploaded on the site. So I would suggest that you must go through the slides, you must go through the videos because that will actually help you understand the topics much better. Okay, and second thing is that I have planned this lecture in a regular manner in which first we will have a recap of the previous conducted session, then we will move on to solving some previous old assignment questions, and we will also look after the numericals. Most of the questions are conceptual questions, so don't worry, you will be able to do these questions very easily. Once you will have to grab the concept. Then we will have a question answer session where I will take up your doubts, and even if you have any doubts, you can always ask me. Okay, so you can just type it in the chat box or speak up in the middle of the session. Okay, let's start this session. The first thing is that we have planned the revision of previous live sessions. So, this revision, we will discuss about the concepts like various formulas which we have used in solving numericals and the graphs or something. So, in previous session, we solved two, three numericals so as to get clear of the fundamentals. You can understand the fundamentals, how what are the capacitance, pseudo capacitance, these things, energy density, power density. So the first formula which we have learned there is capacitance equal to 1 by 2m integral IdV mu into here mu is scan rate and IdV is area under the curve. So why it is integral IdV? I is current, okay, and dV is change voltage or this I current voltage. If there is some curve like this, so IdV will be the area under this curve, the dV area is. So how will you compute this area? This is the main thing. Okay. So if it is like a rectangle, you can just simply multiply the length into breadth, you can calculate the area. When you have a shape something like this, it is quite difficult to calculate the area under this curve. So what we do, we small portions, just integrate it. Okay, that will give area under this curve. It's just adding up the infinitesimally small portions so that we can get the V voltage. Mu is scan rate. Scan rate is basically a concept used for measuring things. We will discuss about it later also. Scan rate. Next, concept was energy density, and energy density is basically a concept used for measuring things. We will discuss about it later also. Scan rate. Next concept was energy density, and next concept was energy density. Next concept was energy density, and next concept was energy density. And next concept was energy density, and power density. So talk about so much of devices, electrical storage devices. So what was and what was the basically energy density that is stored in it? All the devices have different types of energy density, different power density, and these are very important when you consider a thermal storage. Like we go for a battery has uh, some energy. Let's say it has energy storage of 20 watt hour. Okay, but when you go for a lithium-ion battery, why world is preferring lithium-ion? Because it has a very high energy density. It can store 12 watt, 100 watt hour per kg. That's a very high. Only 20 watt hour here 200, like 8 to 10 times. Just don't go by the figures, just see that this much, this is the difference actually. This is how energy density is to be seen in the context. So if we can build a compact system also, and it is always preferable to what you say. I will get to it later. Like it's always better to have a device or something that store energy at a high energy density. And the thing which I was telling to got it later, I want to give you an example. So like think of wood and think of gasoline. Okay, so gasoline, diesel, or anything. So one major thing was that gasoline wood is not generally preferred because wood has the energy density of 20 megajoule per kg. So what's the calorific value of wood? 20 megajoule per kg. But if we see the gasoline, it has energy density of something around 38 to 44 megajoule per kg. It's simply double of the wood. So that's why it is preferred. And high energy density products are always preferred. Okay. So simply if you have to get 100 megajoule of energy, so you will have to burn 5 kg of wood. You will go to market buy 5 kg of wood. But that energy can be given by just for 2.25 kg of gasoline. Okay, so that's how it works. And power density, power, what is power? So in power we have already known that energy per unit time is power. Okay, so divide E by T, you will get the power. Power is just a representation of how much energy which we are consuming per unit time. Okay, that's how power is actually think of. And V here is voltage, is capacitance as you know, and is the discharge time. And another concept was C equal to IDT by V. Simple here, IDT, I current multiplied by time upon voltage, and current here is rate of discharge. With discharge current basically double O discharge, and dt is time taken for the discharge, and V is working voltage. Second, the last thing conceptual which we discussed um, is the graph basically. So if we see the graph here, it says that this is the input. Okay, so what should be its representation in VT? So this can be for battery also. This can be for capacitor also. But what happens in case of capacitor? There is a charging time. Then it discharges. So this is also, this both can be true, but if we see the graph, it gets charging then discharging. So that's why this is actually a much better representation. So answer B is. So any queries here? Any other questions you want to ask? So we'll move to the next. Uh, let's do a numerical also, because we have used the concept. So let's revise the concept. I've changed the value. The question remains the same. I've changed the value, so you can go always calculate. You just have to grab the concept before applying it. So if you can grab the concept, you can apply it in any question. Now let me solve this question. If you see the current versus voltage profile within 2-volt potential window of RGO based electrode of active mass 2.5 milligrams, sold area under the curve as 20.2 milliampere volt. A scan rate of 50 millivolt per second. What would be the capacitance of RGO? So it is asking about the specific capacitance. So you know, anything if you apply the word specific, it is just divided by mass. So here also you will see. So let's see what is there given in the numerical. So you have given B 12 volt, given B equal to 2. M is given 0.5 milligram. Area under the curve is also given, so the area under the curve 20.2. Just write IDV equal to 20. And what is the scan rate? 50 millivolt per second. Scan rate mostly discuss about the frequency of something. I'm not very sure about this word, but just like discussing the speed or frequency with which something is actually transmitted, or so I'll also have to look after it. You can always ask this question on discussion forum. You are encouraged to ask this question, so any of the TA knows or the professor himself can answer. Okay. So let's solve this question. You have to calculate the capacitance, put 1 upon 2 into 2.5 to 2. So let's calculate 20.2 divided by 50 divided by 2 divided by 2 again divided by something around 0.02. Okay, the specific capacitance is 0.02, and since everything is milli, another question. These questions are basically, you know, all these questions, you know the answers. So I put a big thing to discuss here. So we'll discuss these things. We get to know about what is hydrogen economy. That's how these things are actually designed. And these live sessions are there. So it can encourage an interaction between the scholars and the students. So you can always ask, you can always present your views also on hydrogen economy, or hydrogen, how hydrogen can be used as a fuel. Okay. So hydrogen has a high energy density of, see, hydrogen is very energy dense. Kilojoule is simply struck off, should be in megajoule. Okay, so the correct answer can be B or D. So the correct answer can always be B or D simply. So in this case, since there is a high energy, what did I say? Hydrogen is a very high dense energy package. So what happens like such 14 megajoule is basically for normal fuels like gasoline, diesel, or something, and hydrogen is 3 times more energy than gasoline, or it has something around 140 to 150 megajoule per. So that's why whole world is thinking of utilizing this hydrogen. If we have such high energy dense substance or matter available with us, then why we are not using it? The question is why. If hydrogen is such energy dense, then why we are not using hydrogen? This is the question. This question, even the researchers, academicians, politicians, sociologists have coined the term also, hydrogen economy. Everything is with hydrogen only. But hydrogen is such a potent fuel, so it can always be used for economy, running the automobiles, running the industries, everything. So why we are not using hydrogen? So hydrogen, we talk about fuel, so we talked about not only the production cost, production of fuel, good properties also. We include the transportation, third, storage. Production, transportation, storage. So gasoline or petrol. So petrol is actually produced in oil fields. Production is okay. We have technology. We can successfully uh, utilize these technologies. Another thing is transportation. So we have well networked pumps through which pumps, tankers, everything through which this petrol can be easily transported. We have transported it since 50 years, 5 decades, and there has been no problem. Only problem has been inflammability. Sorry, flammability. But if tanker is totally closed, we don't have any fire near around it, so it can be easily transportable. No issue. Another thing is storage. So we can easily store it in tanks, petrol pumps. We have tankers in depot also. They can be stored in big storage containers. But what about hydrogen? So hydrogen can exist in gaseous form. Hydrogen can exist in liquid form when we cool it, and also gaseous in normal thing. Hydrogen is always in gaseous form, but when we liquefy it, it is in liquid form. And another thing is hydrogen can also exist in solid form with like metal hydrides or something. Okay. So in gaseous form, it's very difficult to handle hydrogen because hydrogen is flammable also. First thing, it has a very high calorific value of 140 megajoule per kg. Gases that tends to escape in the environment, so it's very difficult to contain some gas like hydrogen. Another thing is liquid. So for liquid, the main problem is to liquefy the hydrogen, which will take a lot of energy, a lot of time also. And also what happens that when we transport liquid hydrogen, there is sloshing the tanks. Hydrogen is very flammable, highly hazardous, because a single uh, the fire can ignite a bomb, just like a bomb. Because it's such a high energy density, it will release per kg 140 megajoule, just 3 times the petrol. Okay, and 7 to 8 times of the coal. Coal is simply around 28 to 30 megajoule per kg, depending on the varieties of coal. And the peat has very low values, but the bituminous anthracite has 28 megajoule per kg. And so scientists and researchers have actually devised a way, and most of the work is going on in the solid phase. So what we do, we combine the hydrogen with some metal and form metal hydrides, and those metal hydrides can be further put to some other condition to recover the hydrogen when needed. This can be a better way. we can store the hydrogen is what it doesn't uh, so hazardous also. So for this question, the correct answer is D. And for this, you know that storage has been issue, transportation has been issue, production has also been because hydrogen not so easily produced from atmosphere. We have to do electrolysis, and it consumes a lot of it. That's why it's very difficult to get such a highly flammable things to work. The thing is, what are the byproducts in a fuel cell? So you know a fuel cell has anode, anode, cathode, and there are some redox reaction occurring. This anode can be CO2, this can be CO2. Redox reaction occurs in between there. Electron flows in the outer circuit, completing the circuit, providing power. Fuel cells are very important things. These are wonderful ideas which can be harnessed to solve a lot of problems. It doesn't provide only electricity, only give a lot of things. So fuel cells can, as I said, it can be used for a lot of things. It is even used for wastewater treatment also. I, I will tell you guys how it works. First, answer this question: what are the byproducts in a fuel cell? So, byproducts in a fuel cell, there will be a reaction, redox reaction. There can be, and there is water also because we have wastewater treatment activity also with fuel cell going on. Two gas, no N2 gas in power. Don't have N2 gas in electrical energy. This is what the main function is to produce electrical charge or current or electron that goes into the outer circuit. Correct answer is A, B, and D. And how it is used for wastewater treatment? So what happens? So this is a tank. So if we put an anode in, what happens? Is a microbial fuel cell. Remember this in video. The anaerobic digestion reaction occurs here, and due to the bacterial action, electrons are produced, which goes into the outer. So we have got a electron in the outer circuit. We can use this electron as a charge. Since it is a charge, we can pass it through the load, lighting of the load. That's how. At the same time, it is treating the water also. So that's how it is used for wastewater. What does it treat in water? Just bacteria. They have bacteria like microbial fuels. They have bacteria that up the organic content of water. So we will discuss the organic content few slides later. What is the thermodynamic efficiency of a fuel cell? Anything is defined, any system defined with terms of efficiency. Efficiency is a term that actually tells us how the system is performing its function, whether it is a poor performing system or better. Also, we can compare with other systems, like this system is much better in comparison to that. So it is compared in terms of efficiency. So thermodynamic efficiency, this is basically a conceptual question. The correct answer is maximum efficiency of the cell for thermodynamic efficiency. Not average efficiency, it's not minimum, it's not efficiency at the end of user. But the so we see if we see efficiency, what can be the efficiency? Efficiency can be electrical energy produced upon the how electrical energy is produced. So this can be efficiency. This will give a term simple lines we have. What are the major ways to reduce the ohmic losses in a fluid? So again, this question, what is the concept here? So the concept is the ohmic losses. You know, OHM. Ohm is basically attached with resistance. The unit of resistance is okay. Unit of resistance is not social resistance. When I talk about resistance, it's electrical resistance. Okay. Remember, unit of electrical resistance is ohm. So anything which is associated with ohm or resistance losses is called as losses. So what are the major ways to reduce the ohmic losses in a fuel cell? So most of the losses happens because the electrode material is not so conductive. If you use electrode of high conductivity, then losses will be reduced. I will tell you one thing. Like earlier, we had like the most conductive metal is, there can be many, but one of the most widely utilized conductive metal is copper. Another one is aluminum. We have two metals, aluminum and copper, but if we use electrode with higher conductivity, that is thermal conductivity is 85 watt per meter Kelvin. And remember that thermal conductivity and electrical conductivity are very much related. If any metal has a high thermal conductivity, it will mostly have a very high also. Because I will give you an example. The thermal conductivity of copper is much greater than the thermal conductivity of iron. Suppose, so the conductivity of copper is much greater than the thermal conductivity of iron. So if we see the electrical conductivity also, the electrical conductivity of copper will also be greater than the electrical. So this is a simple rule we can keep in mind. There are any question which says about the thermal conductivity? If there are two metals, B has a higher thermal conductivity, assume that B will also have a high electric. Second thing is improve the design. Improve the design always works. Improve the design, make more technological changes, increase efficiency, all these things to reduce the use of appropriate materials for bipolar plates purely because you don't use appropriate material. Like if you use insulator type of material like wood, what will it do? It will block the current itself. It's very difficult to maybe utilize some other material other than the recommended. That's the use of the appropriate material is also good. Making the electrolyte as thin as possible. Because if we make the electrolyte as thick, it is good for the opposite charge. Effective charges to move through the electrolyte or any charges to move the electrolyte. So that's why we always think of possibly reducing the electrolyte size as thin as possible. So all these are correct. Now moving to the question 5. Uh, what is MF? Is real well. And the question is, what is microbial fuel cell? Just remember that microbial fuel cell is a bioelectrochemical device that can generate electricity obtained from the anaerobic oxidation of anaerobic. What is the difference between anaerobic and aerobic? If it is anaerobic, then the process will happen without the presence of no oxygen. So, different types of bacteria actually develops here from the damaging produce methane due to the reaction anaerobic acid. We have anaerobic digester also. If there is aerobic condition, you can expect that mostly it will be CO2 will be more oxygen available for the food generation. These are the microbial fuel cell is basically an electrochemical device, okay, that can generate electricity by use of electrons. So how electrons are, so when this reaction actually occurs, we have electrons pass through the outer circuit. That's how it is. So microbial fuel cell can be used for energy generation, like wastewater treatment, like we discussed earlier. We have a tank filled of wastewater and the organic content in the wastewater. So what does wastewater contain? So wastewater is generally generated from household or some other thing. It has a very high organic content. Organic is carbon, okay? So it will have some organic matter on which this bacteria will work. Make sure that these bacteria works in proper condition, and it is taking up the organic content of the water, so it is actually purifying the water. So done. Another thing is air pollution reduction. Really can not be used for air pollution reduction because air pollution has some particulate matter, SOx, NOx. So these are not the things that can be handled through fuel cell. Another thing is energy storage. So fuel cells are not used for any energy storage. It doesn't have any functionality to store the energy. Just like a redox reaction happens, and then we use the electron to pass through the load. The correct answer is A. Answer B. Okay. You focus on the things. Microbial fuel cells are actually different from the normal fuel cells. Normal fuel cells have redox reaction, but microbial fuel cells have some electrochemical reactions or aerobic reactions. Okay. The working of fuel cell is actually studied. Now the next question. The next question is the reason behind the limited use of fuel cells. So let's take a break for 2 minutes. I would encourage you guys to actually ask questions. See if if anybody of you has asked any questions, you're always welcome. Okay. Start. The reason behind the limited usage of fuel cells are the reason behind the limited usage of fuel cells. Again, the same question like we discussed in the hydrogen. If fuel cells are so can be used for so many areas, so why they are limited use? So, single thing is that used gases are flammable. Can happen. Whatever is used in the fuel cell is actually flammable. So, quite risk hazardous. Storage is difficult. Very difficult to store gases which go for reaction reaction. Another thing is cost because we need to make a new device to harness the energy. Is always there and Actually, the fuel cell thing is not very well developed also, not very much exploited on the commercial scale. It's quite difficult to actually implement these systems because of the cost. Another thing is emission of greenhouse gases. The correct answer is all the four, and we'll discuss what are the greenhouse. How do we measure them? How do we measure emission? If you know, greenhouse gases are gases emitted from the mind to other people's. You just have to understand what the greenhouse gas. Mostly it's CO2, CH4, and in greenhouse gas quantification we measure the impact of greenhouse gases on these planet. Sorry, our planet. Greenhouse gases are actually the term greenhouse is actually derived from greenhouses that are used to keep the plants warm in winter. That's where the term greenhouse gases. So we actually use the protective cover, outside cover, to actually keep the plants warm even if it's cold outside. So that's how the term greenhouse, and the effect is somewhat similar to the what's observed in that greenhouse. So what happens here? It's still lovely. We're not allowed to go like this. You can go in the warming phenomena is observed in that. A similar case for our planet Earth also. So what is happening? The Earth is expanding actually. And this expansion is very much linked to the production of greenhouse gases. And also, we actually measure it in terms of global warming potential, how potent these gases are in terms of global warming. The main thing is that you have to evaluate also. Evaluate also. These global warming potential for all these gases are actually not same, but it is different for different gases. Like CO2 is taken as reference, so it is allotted a value 1 arbitrarily. Okay, and whatever thing we think, it is actually a different representation of the same. We just put the impact there. So that's why if CO2 is 1, then CH4 is given potency of 21. That means CO2 is 21 times more potent to damage the environment to greenhouse gas than. That's why these gases have to be tracked and studied, and their impact on different environmental system has also to be studied very properly, very carefully. Okay, now moving to the next question. We have numerical here. This numerical is actually from the previous live session. I have put this numerical so as to make you familiar with the use of formulas, that you be familiar with these things. Solve this numerical also, and to make you familiar with the energy density and power density terms. What does it say? A supercapacitor with a maximum voltage of 1.6 volt can give 16 farad 16 farad per gram capacity. 16 farad per gram. Type of the specific capacity. What should be the energy density and power density? Energy density and power density. Considering device would fully discharge in 60. So energy density is half CV square. Is capacitance 16 farad per gram at given. V is voltage 1.6 volt, and their time is given for calculating the power density. So if you put there is 1 by 2, 16 farad per gram into 1.6 whole square So that comes out to be 5.7 watt hour per kg. So divide it by time, it comes out to be 134 watt hour. Okay. Correct answer is, if there are any other numbers, you can easily solve it according to the given empirical relation or fundamental relation. So thank you guys for attending this live session. It was a very wonderful session with all you guys, and the questions you asked were really good. And if there are any queries which you want to ask or which you can't ask in this session, you can always post them on discussion forum. Basic thing is that let everyone benefit from the discussion. Please can go and see your answers. The professor himself can give it answers. Okay, so that's how we will end this session. Thank you all. All other queries are very much welcome. You can always find me at this email. We will meet at next Saturday.